Welcome back to Math 171 Pre-Calculus Algebra. In this video, we're going to take a look at logistic growth models. So I made mention in the last video that exponential growth can only be used to estimate population growth or evolution of a disease for the short term. That longer terms we end up getting a problem because an exponential growth model is going to grow forever, and a lot of things can't do that forever. So we end up with a more realistic growth function looking like A equals C over 1 plus A e to the minus b t. Where we have a couple of important things in here. C is going to be the carrying capacity. Which for a case like population, it's going to be the population that the environment can sustain. You're probably not going to be able to sustain 500 fish in a small fish bowl. So your C is going to be whatever the maximum you could sustain is. And then the other important thing to remember is that C divided by 1 plus A is going to be the initial value. So that's the value at time, whatever you're declaring to be times 0. So sometimes you'll see when it comes to evolution of a disease, when the case or disease is first discovered, but a lot of times that's just going to end up being some arbitrary point in time. So we might get something like this. So a model that looks like f of t is equal to 30,000 divided by 1 plus 20 e to the minus 1.5 t. And then we could ask ourselves several questions about this, but anything we'd be doing from here would just be applying what we've done before, so we're not really going to get into much with this one, because there's so many different things you could be asked, and everything you'd be asked to do we've done before. So that'll conclude this video. In the next video, we're going to talk about Newton's law of cooling and how we can work with that.